we have finding range of a rational function. So, kung natay domain, naapod tay range, of course. So, range is a set of all real numbers that satisfy the rational function f of x. Or, range are all is the set of all real numbers or valid output. Meaning, kung natay valid input, napod tay valid output. Kana bang inig-input nimo dapat kadto silang mga values mo to sila manggawas. Kay mo to sila inig-evaluate nimo sa rational function ba ang katong mga manggawas nga mga values sa imong valid and every valid input naapod tay valid output. So partner man na sila no, input output kato akong kung ma-recall ninyo sa rational I mean sa introduction to functions, the input and output process. Okay, so kung ma-remember na inyo class, mao ni siya ang output, our range. Now, in finding for the range of a rational function, we have to identify also the horizontal asymptote. Okay, so asymptote gihapon ni siya class, ang nakalahi lang is horizontal or nagpahigda ni siya. So, a horizontal asymptote is a line of the form y equals to b, which the curve approaches but never touches. Okay, so si horizontal asymptote class, siya ang number na miskan unsay number input nimo class, dili gyud na siya mugawas as our y value. Okay? Because again, our range are y values katong valid output. Okay? So, ang kanang horizontal asymptote, miskan unsa nga number imong i-evaluate sa imong rational function, kana siya nga number, dili yun na siya mugawas. Okay? So, dili siya mugawas, therefore, horizontal asymptote siya. Okay? So, to determine the horizontal asymptote of a rational function, f of x that is equals to p of x over q of x, the degrees of numerator and denominator will be considered. Let n and m be the degree of p of x and q of x respectively. Kani siya class, dili na in finding for the range and horizontal asymptote, dili na ta kailangan mag-solve. Pwede gud gyapon nato siya i-solve algebraically like pareha tong sa domain, but in this case, pwede nato siya i-shortcut. For our rational function, we have p of x as our numerator and then ang n, okay, variable n will be the highest exponent. We also have q of x, our denominator, and then ang ihapong highest exponent is m. Okay? First, we have if n, again, n is the highest exponent or the degree of our numerator, and then m is for the denominator. So, if n is less than m, the horizontal asymptote of f of x is the line y equal to 0. So, automatic nga y equal to 0 ang iyahang horizontal asymptote. For letter B, if n is equal to m, so meaning parehas og degree ang numerator and denominator, the horizontal asymptote is y equals to a sub n over b sub n, where a sub n is the leading coefficient of p of x. Okay, when we say leading coefficient, it is the numerical coefficient of the term with the highest exponent, no? Term with the highest exponent. Say for example, moingon ka og 4x 4x squared minus 2x plus 1. Okay, so in this example, we have 4x squared minus 2x plus 1. In this polynomial class, ang term with the highest exponent, of course, is 4x squared. Okay, kung mingon kag leading coefficient, ang leading coefficient nato dire will be the number 4. Ngano man, siya man ang numerical coefficient sa term with the highest exponent. Pinakataas ng exponent. We have x squared. 2 ang iyahang exponent. So therefore, 4 here, kaninga 4, is the leading coefficient. Okay? So, kana. So, balik ta sa ato ang letter B condition. We have, if n is equals to m, again, the degree of our numerator is equal to the degree of our denominator, the horizontal asymptote is y that is equals to a sub n over b sub n, where a sub n is the leading coefficient of p of x and b sub m is the leading coefficient of q of x. So meaning, i-divide lang nimo ang leading coefficient sa imuhang numerator and denominator. Leading coefficient lang, katong numbers, numerical coefficients. Okay? Next, we have if n is greater than m, meaning the exponent or the degree of our numerator is greater than the denominator, then there is no horizontal asymptote. Wala siya horizontal asymptote. But we'll focus more on rational functions which has horizontal and vertical asymptotes. Okay? So we have here example in finding the range of a rational function. So find the range of each of the following rational functions. For number 1, we have y equals to 1 over x. Number 2, we have y equals to 1 over x minus 1. Number 3, we have y equals to 5 over x squared minus 4x plus 3. Number 4, we have y that is equals to x minus 3 over x squared minus 3. For number 5, we have y that is equals to 5 minus x over 2. And for number 6, we have f of x that is equals to 3x plus 1 over 4x minus 1. An example in finding the range of a rational function, we have y that is equals to 1 over x. So just like finding the domain of a rational function, in finding for the range, we'll have to get first or identify first the horizontal asymptote. Now, in finding for the horizontal asymptote, diba, we have three conditions. First, if the degree of our numerator is less than the degree of denominator, then automatic na nga to ang horizontal asymptote will be y equals to 0. Second, if the degree of our numerator is equal to the degree of our denominator, then the horizontal asymptote will be y equals to the ratio of the leading coefficient of numerator and denominator. And lastly, if the degree of our numerator is greater than the degree of our denominator, then we'll have no horizontal asymptote, no? So in our given, we have y that is equals to 1 over x. So since our numerator is a constant 1 and we have denominator which is x, this means that the degree of our numerator is less than the degree of our denominator. So for our horizontal asymptote, we'll have y that is equals to 0. First condition man siya. Because again, our numerator is constant and then we have the denominator which is tawag ani x, no? Okay, we have x. So ang degree sa atong numerator is less than the degree of our denominator. Therefore, we'll have y that is equals to 0 for our horizontal asymptote. So since we have identified our horizontal asymptote, we can now determine our range. So our range is the set of all numbers except our horizontal asymptote. Meaning, tanang miskan unsang x value ang imuhang i-input, dili jud ta makakitag output or y value na 0. So, mo na siya ang atong horizontal asymptote. So, therefore, for our range, we have the set of all real numbers except our horizontal asymptote, which is 0. Okay? So, this will be the range of our rational function. So, ana lang mangita og range. For our number 2 example, we have the given y that is equals to 1 over x minus 1. So, again, in determining the range of a given rational function, ang una nato buhaton is to find for our horizontal asymptote. So again, in finding for the horizontal asymptote, we only have three conditions, no? So first condition again, if the degree of our numerator is less than the degree of our denominator, therefore our horizontal asymptote is y equals 0. And if the degree of both numerator and denominator are equal, therefore our degree, or I mean our horizontal asymptote, will have y is equals to the ratio of the numerical coefficients, leading numerical coefficients of numerator and denominator. And if our, or the degree of our numerator is less than the degree of our denominator, therefore we'll have no horizontal asymptote. So let's take a look at our given. So again, ang given nato, we have y equals to 1 over x minus 1. So ang numerator nato is constant, no? And then we have x minus 1 as for our denominator. So the degree of our numerator na constant 1 is less than the degree of our denominator, which is x minus 1. So therefore our horizontal asymptote will have y that is equals to 0. So since na natay horizontal asymptote, we can now determine our range. So again, our range is the set of all numbers except the value of our horizontal asymptote. So we'll have the range is the set of all real numbers except our horizontal asymptote, which is 0. So mo ni siya ang range sa ato ang given sa number 2 example. So the range of the function y equals to 1 over x minus 1 is the set of all real numbers except 0. Okay? For our number 3 given, we have y that is equals to 5 over x squared minus 4x plus 3. So again, in finding for the range of a rational function, ang first na to identify is the horizontal asymptote. So if we are going to take a look with our example, or the given for our example number 3, we have 5 for the numerator and x squared minus 4x plus 3 as our denominator. So in this case, the degree of our numerator is less than the degree of our denominator. So therefore, our horizontal asymptote will have y that is equals to 0. So since na natay horizontal asymptote, we can now determine the range of our rational function. So for our range, again, our range, we have the set of all real numbers except our horizontal asymptote, which is 0. Okay, so therefore the range of our function or rational function, that is y equals to 5 over x squared minus 4x plus 3, is the set of all real numbers except 0. For our number 4 example, we have the given y that is equals to x minus 3 over x squared minus 3. So in identifying or determining our range for the rational, for a given rational function, again, ang una nato buhaton is to identify our horizontal asymptote. So in identifying horizontal asymptote, tanawon lang nato ang degree sa numerator and denominator. So for our numerator, we have x minus 3. For our denominator, we have x squared minus 3. So ang degree sa ato ang numerator is 1. Ang degree sa ato ang denominator is 2. Meaning, si 1 is less than 2. So the degree of our numerator is less than the degree of our denominator. Therefore, our horizontal asymptote will have y that is equal to 0. Okay, now, na naman tayo horizontal asymptote. So, we can now identify our range. So, again, our range is the set of all real numbers except for our horizontal asymptote, which is 0. So the range of the function y equals to x minus 3 over x squared minus 3. We have the set of all real numbers except 0. For our number 5 example, we have the given y that is equals to 5 minus x over 2. So again, in determining the range of a rational function, ang una nato buhaton is to identify our horizontal asymptote. Now again, in identifying our horizontal asymptote, we have three conditions. First, if the degree of our numerator is less than the degree of our denominator, therefore the horizontal asymptote will be y equals to 0. Second, if the degree of the numerator and denominator are equal, so the horizontal asymptote will be y equals to the numerical, I mean the ratio of the leading coefficients of numerator and denominator. Lastly, if the degree of our numerator is greater than the degree of our denominator, therefore we'll have no horizontal asymptote. So since our given, we have 5 minus x as our numerator and we have the constant 2 as our denominator. Diba na may x ang atong numerator and then sa ato ang denominator wala na tay variable. So this means that the degree of our numerator is greater than the degree of our denominator. So maswak siya sa condition 3. So therefore, the rational function has no horizontal asymptote because again the degree of our numerator is greater than the degree of the denominator, therefore we'll have no horizontal asymptote. So since na-identify nato na wala tay horizontal asymptote, for our range we'll have the set of all real numbers. Okay, since no horizontal asymptote man ta, therefore the range of the function is the set of all real numbers. Wala man tayo horizontal asymptote, therefore all real numbers are can be arranged or can be the range of the set of all real numbers will be the range of our rational function na y equals to 5 minus x over 2. For our last example, we have the given f of x that is equals to 3x plus 1 over 4x minus 1. So again, in identifying the range of a rational function, ang una nato i-identify will be our horizontal asymptote. Now again, in finding for the horizontal asymptote, ang tan-aw lang nato are the degrees of our numerator and denominator. So for our numerator, we have 3x plus 1. We have ang iyahang degree is 1 kay di ba 1 man ang exponent dira. So ang term with the highest exponent man is ang 3x because ang 1 nato is constant. Sa denominator pod, we have 4x minus 1. Ang degree pod niya is also 1. Na diha no sa taas, invisible lang siya. So, since the degree of numerator is equal to the degree of the denominator, therefore, for our horizontal asymptote, we'll just have to get the leading numerical coefficient of numerator, which is 3. I-divide lang nato siya sa leading coefficient of our denominator, which is si 4. So, we'll have 4. Wala naman tayo ma-simplify. Therefore, our horizontal asymptote will be y equals to 3 over 4. Okay? So, since na-identify na nato ang horizontal asymptote, we can now determine our range. So, for our range, it is the set of all real numbers except our horizontal asymptote, which is 3 over 4, or we have 3/4. So the range of the function f of x, that is equals to 3x plus 1 over 4x minus 1, is the set of all real numbers except 3/4. Okay?